All right, now we're going to look at reactions of alcohols. So we've just seen that we can hydrate alkenes. You can add water to an alkene and form an alcohol. You can also do the reverse. You can dehydrate an alcohol to get back to the alkene. We're just going to have a look at what that's going to look like. So I'm starting here with an alcohol, and if I heat it in the presence of a catalyst, I can turn it back into an alkene. Now, the words dehydrate, they imply that we are going to lose H2O. And if I look at what I've got in my alcohol, there's my OH, all right? That's the only oxygen I've got, so that's definitely going to go. But I need to lose 2 hydrogens, and so far I've only got 1. The rule is, whatever carbon has the OH, you go to its neighbour and you remove 1 hydrogen. Now, it doesn't matter which one of these hydrogens I lose, but one of those hydrogens has got to go. So 1 carbon loses the OH, the neighbouring carbon loses a H, and that's where I'm getting the H2O that ends up here as my extra product. So what I'm going to do then is just draw this molecule again without that H and without that OH. I keep my C, I put in my hydrogens, my remaining hydrogens, and this is what I'm left with. Now, this can't exist because carbon only has 3 bonds, which means I need to put a double bond between them. So I've gone from ethanol to ethene, the alcohol, to the alkene by dehydrating it. If we have a look at another one, all right, it's the same story. This time I've drawn out propanol. Okay, again, if I'm dehydrating it, I'm losing H2O. That's the OH, but I need another H. The rule is the carbon with the OH, you go to its neighbour and you remove one of those H's. Up or down, doesn't matter. I'm going to take the one from the top. If that's what I'm losing, then I draw everything else. Okay, so I've lost that OH, but I'm keeping that H, I'm keeping that H. I've lost that one, but I'm keeping that one, that one, that one, and that one. And again, we can see that these 2 carbons only have 3 bonds, so I'm going to be putting a double bond between them. So I've gone from propanol to propene by removing H2O, and there's my H2O as my extra product. Look at maybe kind of a slightly more awkward example. All right, so I've got butanol here, and I've got this drawn out twice because there's technically 2 things that I can do with this one. Again, I'm heating it, so I know I'm going to be dehydrating it, and that means I'm losing H2O. So I can lose an OH there, but if I go to the neighbour, I've actually got 2 neighbours that both have hydrogens. Okay, so let's say I go to the neighbour on the left and I remove a hydrogen from the left hand side. What will I be left with? Well, I'll have this H and this H will still be there, so will that one, that one, that one, that, and that. And it's these 2 carbons here at the end of the chain that are missing a bond and that they need the double. So I'm forming buth1-ene. However, my other option, I have to take that OH, there's no other choice, but what if I go to the right and I remove this hydrogen here, which I'm just going to highlight this one here in blue. What if I remove that hydrogen instead? So that means I would still have all 3 hydrogens here, so I'm not removing that first hydrogen anymore. The OH is going to go, the H is now going to go, and those 3 hydrogens still stay on the end. So I'm still removing H2O, I've just taken the H from the other side of the OH. But what that does is it actually moves the double bond in my product, and instead of forming buth1-ene, I'm forming buth2-ene. So it's only when you've got 4 carbons that's going to be an issue, but instead of having buth1-ene, I've now got buth2-ene because I've taken the hydrogen from the other side. Both of these things are possible, they'll both happen. If you have this molecule and you try and dehydrate it, you're going to form a mixture of these 2 products, and you're also going to form H2O. Alright, so in summary, this reaction here is reversible. You can take an alkene, react it with water and form an alcohol. But similarly, you can take an alcohol, you can dehydrate it and get back to the alkene and the water. The other reaction of alcohols you need to be aware of is oxidation. And these are quite straightforward. You just need to know that you can oxidize an alcohol and turn it into a carboxylic acid. Now, because I'm oxidizing it, I'm going to be reacting it with oxygen. You do this in the presence of what we call an oxidizing agent, but for the purpose of this at GCSE, we can just write O2. So if I'm oxidizing this, I'm starting off with an alcohol. I'm starting off with methanol. I'm going to turn it into a carboxylic acid, and it's just the corresponding carboxylic acid. So if there's one carbon in my alcohol, there's still one carbon in my carboxylic acid. So I've got one carbon. I draw my carboxylic acid functional group. I can see that carbon's missing a bond. That's going to go to a hydrogen. So I've gone from methanol to methanoic acid by reacting with oxygen. Water is an extra product here. The next one, I haven't drawn it for you, all right, but it's ethanol plus O2. Because it's oxygen, I know I'm going to be oxidizing it. And if I'm oxidizing, I'm going from an alcohol to a carboxylic acid, and it's going to be ethanoic acid. So the number of carbons stays the same. It's just the functional group that changes. And I could draw that out if I wanted. 2 carbons, double bond O, single bond OH, and then fill in your hydrogens. Last one I've got here, I haven't drawn this out, okay, so if you don't like this, you can absolutely draw it out in full, but there's 3 carbons and there's an OH. So I'm starting here with propanol, I'm oxidizing it, I'm going to be forming propanoic acid. Now, just because they've written it in that form doesn't mean you have to stick with that form in your answer. If you're more comfortable drawing propanoic acid in full, then that's exactly what you've got to do. You don't need to write it in the same type of formula. You can draw it out in full, and that's what you should do if you're more comfortable with this. So starting with propanol, oxidizing it, forming propanoic acid. So that's your key message. If you oxidize an alcohol, reacting with oxygen, you will just form the corresponding carboxylic acid. You always form a molecule of water, 1 molecule of water for every alcohol functional group that you oxidize.